Okay, so I am just going to try something a little different. Go through the answer cue for the review in video format. So, first question talks about geometric means. Geometric means are values that fit the idea of x over a equals b over x, where a and b are the numbers and x is what you're solving for. So when I'm given 8 and 12, looking for the geometric means, I'm going to do x over 8 equals 12 over x. Then we are going to cross multiply to solve. X times x is x squared. 8 times 12 is 96. To get rid of squared, we take the square root. Since we're rounding to the nearest hundredth, that means 2 decimal places. X is 9 point. Now it says 7979589, etc., which means the second 7 makes the 9 increase, and the 9 makes the 7 increase in turn, so 9.80. Okay, problem B, square root of 2 over x equals x over square root of 3. Now you'll notice I put the x's in the opposite spots. I didn't mean to do that, but geometric means can be written in either direction. So x times x is x squared. Square root of 2 times square root of 3 is square root of 6. To get rid of a squared, I take the square root. Now here, I'm going to have the square root of the square root of 6. So I'm going to have to put 2 square roots in. X ends up being 1.57 when rounded to the nearest hundredth. 23 square roots of 5 over x equals x over 4 square roots of 8. I cross multiply. X times x is x squared. 23 square roots of 5 times 4 square roots of 8 is 92 square roots of 40, because 23 times 4 is 92. Square root of 5 times square root of 8 is square root of 40. To get rid of a squared, I take the square root. Make sure all of that ends up underneath the square root, and I end up with x is 24.12. Last but not least, x over square root of 7 equals 5 square roots of 3 over x. Honestly, at this point, I hope that if you're watching this piece still, you're really just watching because of the challenge of this individual problem. I hope that watching the first few makes sense for you to finish the rest. That's essentially the goal throughout this. X times x is x squared. 5 square roots of 3 times 7 is 5 square roots of 21. Because remember, number outside of square roots multiply with numbers outside, inside with inside. Square root of 5 square roots of 21 is 4.79 when rounded correctly. To determine if a triangle is possible, essentially what you need is the 2 smallest sides to add up to something bigger than the third side. So I have to identify which side would be my largest side first, add the other two, and 19 plus 27 is 46, and check, is that bigger than the third side? 46 is indeed bigger than 43, so yes, the triangle is possible. In ones where I have square roots involved, I go to my calculator and type in what the square root is just to kind of figure out what it's about. Square root of 8 is about 2.83. Now, once I know that 9 is the biggest. And when I go to add up my 2 smallers, I don't use the 2.83, I use the square root of 8. Square root of 8 plus 5, I type that into my calculator. It's equal to about, because I have to round, 7.83. 3, which I just have to check. Is that bigger than 9? And no, it's not. So, no. Triangle is not possible. Okay, last one. Biggest is 30. Add up the other two. 12 plus 18 is 30, and 30 is also not bigger than 30. It's equal to. Equal to is not good enough. Has to be bigger. So that just checks if a triangle is possible. If a triangle is possible, you might have to classify it as acute, obtuse, or right. This relies on the converse of the Pythagorean theorem as well as the Pythagorean inequality theorems, which essentially say use your c squared equals a squared plus b squared. Figure out if both sides of the equation are equal, or if c squared is bigger or c squared is smaller. Start by identifying the biggest side. That, in my Pythagorean theorem, that always has to go in the c part. Always has to be the largest, aka in a right triangle, the hypotenuse. So 15 squared equals 12 squared plus 9 squared. 15 squared is 225. 12 squared is 144. And 9 squared is 81. 144 plus 81 happens to be 225. And since they are equal, it is a right triangle. Okay, next one, 5 square roots of 6, 12, and 17. Well, 5 square roots of 6 is about 12.25. Now, when I write the equation, I do not write the decimal form. I use the exact form. But I need to know which side's biggest, so I need to know what it is in reference as a decimal in order to recognize that the 17 is the biggest. So 17 squared might be equal to 5 squared to 6 squared. Now this needs parentheses. Plus 12 squared. 17 squared, I believe, is 289. Yep, 289. Now, 5 square roots of 6 squared. When I type that into a calculator, I need that open parenthesis. I also, if I have a TI graphing calculator, particularly one of the older ones, I need to make sure that I double close parentheses before squaring it. This should be 150. If you only got sorry, don't mind me. If you only got 30, you did not square things correctly. You did not close parentheses correctly is going to be the bigger issue, most likely. 12 squared is 144. 144 plus 150 is 294. Now these are clearly not equal. That means it's not a right triangle. And always look at the c squared part. That's the, in this case, this piece. Is that bigger or smaller? If it is smaller, like in this case, it is an acute triangle. If it's bigger, it would be obtuse. Okay, biggest side, that goes in the C spot. Square the things. Since my c squared is bigger, it is an obtuse triangle. For the sake of ones like this next one where you got some real ugly numbers, start by figuring out what they're equal to as decimals, not because that's what you're going to plug in, but because you need to know which one's biggest. So these are each of them in order. That one's the biggest. So that's the one that goes alone on its side of the equal sign. That goes in the C spot of Pythagorean theorem. Now keep in mind that it needs parentheses, and I need to make sure I'm typing it into my calculator correctly. Five square roots of 15 squared is 375. 4 square roots of 12 squared is 192. 4 square roots of 2 squared is 32. 375 equals 192 plus 32 is 224. This one is definitely bigger, therefore it is obtuse. It's always if that C squared is bigger, smaller, or equal. Now, to evaluate the following literally just means type this into your calculator. Rounding to the nearest hundredth means 2 decimal places, so 0.66 here. Sine of 82, 0.99. Neither of those is an angle. Trig goes of an angle, does not give you an angle. Inverse trig, on the other hand, does give you angles. Remember, if it's fractions, it has to go in parentheses. 40 point, I'm still rounding to the nearest hundredth, so 40.60. And 55.93. If you don't put the degrees, it's not the end of the world. Now we're moving into solving. Now, when solving, we've got a number of tools we can use. We have our SOHCAHTOA, our trigonometry, in other words. We have Pythagorean theorem. We have the fact that angles have a sum of 180 degrees. We have inverse version of trig. And technically, we also have special right triangles. Now, I'll be honest with you. You never have to use special right triangles if you know how to use SOHCAHTOA, trig, Pythagorean theorem, and the triangle angle sum theorem. You never need special rights. I don't use special rights most of the time. If you recognize you have a 45-45-90 triangle or a 30-60-90 triangle, you're welcome to do that, though. Okay. So, 6A. I personally would go about and work with trig because I notice it's a mixture of sides and angles. That's my angle of reference, making this the opposite. This is my hypotenuse because it's across from the right angle. This is the adjacent. Now I want to solve for the variables here, which I have both x and y. I can make my choice on which one to solve for first. I'm going to go with x. The opposite is not helpful in this. So I've got adjacent and hypotenuse, which should be cosine then. Cosine of the angle equals the adjacent divided by the hypotenuse. When the variable's in the denominator, or in the fraction, I multiply by the denominator. X is not alone, so I divide because it's being multiplied by cosine of 60. So x is equal to whatever 5 divided by cosine of 60 is. Oops, I wrote the wrong thing in my calculator. And the calculator will give me that x is 10. I also want to solve for y. I can use Pythagorean theorem or trig here, or this is a special right triangle, and we'll talk about that here in a bit. If I choose to do trig again, now I'm going to use the opposite and the adjacent. Yeah, I could use the hypotenuse. It's easy enough to work with, but I'm not going to. Opposite and adjacent will be tangent of the angle equals opposites y over the adjacent is 5. And when the variable is in the fraction, I multiply by the denominator. So that cancels out. Y is now alone, and 5 times tangent of 60 is equal to 8.66 when rounded to the nearest hundredth. Now you could have treated this as special right triangles. If you had done so, this side would have been k, this side would have been k times the square root of 3, and this side would have been 2k. You would have solved this, said k was 5, therefore the hypotenuse, which was 2k, would have been 2 times 5, therefore x was 10, and y would have been k, or 5, times the square root of 3, which wouldn't have simplified at all. And 5 square roots of 3 is equivalent to 8.66. There's 2 different ways to solve there. I don't care which way you do this. I personally do not use special right triangles very often anymore. Okay, anyway. Okay, next problem is not a special right triangle, but I notice I'm working with angles and sides together, so I'm doing trig. That's my angle of reference. This is the opposite. This is the adjacent. The hypotenuse has no labels, so it's not helpful. Opposite and adjacent is tangent. So, tangent of the angle equals the opposite divided by the adjacent. When the variable is in the fraction, you always multiply by the denominator. X times tangent of 43 is 10. X is not alone. So I divide by tangent of 43 because x is being multiplied by it. 10 divided by tangent of 43 is what I type into my calculator. I end up with 10.72. Okay, moving on to C. Here's my angle I'm looking for. I'm looking for angles and sides together, so I'm doing trig again. That's my opposite. It's not labeled, so it's not helpful. This is my hypotenuse. This is my adjacent. Adjacent and hypotenuse is cosine. Cosine. Now it's always of the angle, which in this case is x, equals. Then it's the adjacent divided by the hypotenuse. When the variable is inside of the trig ratio, stuck in that angle, you're going to use inverse trig. So I'm going to use cosine inverse of this. X is whatever cosine inverse of 8/15 is. Now this is an angle, and when I'm solving for an angle, according to the instructions, I'm rounding to the nearest degree. Be careful of that. This is 58 degrees. Now, this next problem is only working with side lengths. When you're only working with side lengths, you're doing Pythagorean theorem. Now, you have to recognize the hypotenuse. You're not always solving for the c squared part. This is my hypotenuse because it's across from the right angle. That's what goes in the C position of Pythagorean theorem. So this is the C. I don't care which one's A and which one's B. X squared plus square root of 14 squared equals square root of 15 squared. X squared plus square root of 14 squared is 14. Square root of 15 squared is 15. I need to get the x alone, so I'm going to subtract the 14 first. X squared equals 1. To get rid of a square root, I take a square root. Square root of 1 happens to be 1. Problem E is mixing together angles and sides again, so I'm thinking trig. That's my angle of reference. This is my opposite. This is my hypotenuse. Opposite and hypotenuse is sine. Sine of the angle equals the opposite divided by the hypotenuse. When the variable is in the fraction, you multiply by the denominator. X times sine of 29 equals 17. Since x is not alone, I'm going to divide by sine of 29. 17 divided by sine of 29. It's the side length, so round to the nearest hundredth is 35.07. F is also mixing sides and angles. There is my angle of reference. That's the opposite. This is across from the right angles, the hypotenuse, which means this must be the adjacent. Adjacent and hypotenuse, I'm using cosine. Cosine of the angle equals the adjacent divided by the hypotenuse. Variables in the fraction, you multiply by the denominator. So I multiply by 11. X is alone now, so 11 times cosine of 59 is the math I'm doing. And I get 5.67 because I'm solving for a side length. I'm rounding to the nearest hundredth. Question G is mixing sides and angles again. There's my angle of reference. That's the opposite. That is the adjacent. The hypotenuse is unlabeled, therefore not helpful. Opposite and adjacent is tangent of the angle equals that opposite divided by the adjacent for SOHCAHTOA. Since the variable is inside the trig, to get rid of the trig, I do inverse trig. In this case, inverse tangent. X is equal to, those will cancel out, leaving me with x, and x is going to be equal to whatever tangent inverse of 11 divided by 8 is. Solving for an angle, so I round to the nearest degree, which is 54. H is working with side lengths only. So I'm thinking Pythagorean theorem. That's my hypotenuse. So square root of 101 plus 12 squared equals my x squared. This is 101. This is 144. 101 plus 144 is 245. To get rid of a squared, you take the square root. We get 15.65. Last problem on this page is solving for x. It is also a mixture of angles and sides, so I'm thinking trig. That's the opposite. That's the hypotenuse. My last side is unmarked, and therefore My adjacent's not helpful. Opposite and hypotenuse is sine. Sine of x is equal to 5 over 7. I sine inverse both sides. Because my variable is my angle. Sine inverse of 5/7, rounded to the nearest degree because it's an angle, is 46 degrees. Now these next two are special right triangles. I can do trig, but I've done so much trig so far on this answer key, I'm probably going to do these ones, mainly focused on those special rights. On a 45, 45, 90 triangle, the legs are k, the hypotenuse is k times the square root of 2. The side length I can solve for is this one because that's the only one that's a number. And if I set those equal to one another, 6 square roots of 2 equals k times square root of 2. To get k alone, I'm dividing by the square root of 2, and the square roots of 2 are canceling on both sides. K is just 6, which means both m and n are 6. Now, I could have done trig on this one. It would have worked out beautifully. Here would have been my angle of reference. This would have been the opposite. This would have been the adjacent. This would have been the hypotenuse. And I would have set up the trig ratios if I was solving for m first, for example. I would have done sine of 45 equals m over 6 square roots of 2. Would have multiplied by 6 square roots of 2 on both sides. And I would have ended up with m still being equal to 6. Same idea on n. If I had done trig, I would have ended up doing cosine of 45 equal to n over 6 square roots of 2, multiplied both sides by 6 square roots of 2, and n would have been 6. I don't care which way you solve it. Special rights have 2 ways to solve now. Either is fine. Solving this one is a 30, 60, 90 triangle. If I'd done special rights, this would have been k, this would have been 2k, and this would have been k times the square root of 3. This is the one I can solve. 2 square roots of 3 is equal to 2k. To get k alone, we divide by 2. And k would have been the square root of 3. Meaning, y would have been the square root of 3. And x, which was square root of 3, that's because that's k, times the square root of 3, that would have become the square root of 9, which is 3. Had I done my trig, this would have been my angle of reference. X would have been the opposite. Y would have been the adjacent. This is the hypotenuse. Oops, let's not do that. Let's do this instead. I'm going to solve for x first. Opposite and hypotenuse is going to be what I'm working with then. So sine, I would have done sine of 60 equals x over 2 square roots of 3. I would have multiplied by 2 square roots of 3 on both sides. I would have then had this alone, type it into my calculator, x would have been 3. I would have then solved for y, which would have given me cosine of the 60 degrees equal to y over the 2 square roots of 3. I would have multiplied both sides by the 2 root 3 because the variable is in the fraction. Those would have canceled out. And 2 square roots of 3 times cosine of 60 degrees would have been y, which I would have gotten 1.73, which is equivalent to the square root of 3. So I don't care if you did it the top way or the bottom way. You don't have to do both. Same on this one. I don't care if you did it the top way or the bottom way. You do not need to do both. Okay. Now these ones, when you have the situation where you see these overlapping triangles, generally speaking, you are going to have a special right triangle. Now there's supposed to be a right angle here, by the way. I need to fix that. So, here's where I draw my 3 triangles, all orientated the same way. I personally orientate them the same way as the big triangle. So that's my right angle, that's my right angle, that's my right angle. My big triangle is JLK. I make one angle mark and a double angle mark. I'm going to choose to do that way. Now I'm going to move in. I'm going to choose the bigger of the 2 small triangles next. The right angle's M. It has the single marked angle K on top. And then it has L as its 3rd corner. The one on the bottom, the right angle is M. It's got the double marked angle, which goes on the bottom because I want to match the first triangle I drew. But that's at J, and the 3rd corner is L. Now I know that KJ, going from here to here, is 25. JL is Y, KL is Z. LM is X, and it's on, oops, I forgot to write the L there. It's on both triangles. JL, I forgot to put that on both triangles, was Y. I also forgot KL went on 2 triangles, was both Z. KM is 20. And JM is 5. Now, when you're doing this, remember you're matching up sides. So if I want to solve for X on this X goes with this 5. And I can work the 20 and the X then. So X over 5 equals 20 over X. Cross multiply to solve. We get X is 10. Okay. Now I want to solve for Y. Y is here. It can be paired up with the 5, which would give me the 25 and the Y together. Y over 5 equals 25 over Y. And we cross multiply to solve. We end up with Y being equal to 11.18. Last but not least, I want to solve for Z. Z goes with the 20, and I can put the 25 with the Z between those 2 triangles. Make sure when you're making your proportions, you're only working with 2 triangles at a time. Z over 20 equals 25 over Z. 20 times 25 is 500. And the square root of 500 is 22.36. Okay. M. Same idea. 3 triangles. Oops. That's not what I meant. That's not what I'm trying to do. Stop it. There we go. There's 1. There's 2. I ran myself out of room. There's 3. There's no letters on this one, so I'm going to add some letters. I'll call that A, I'll call that B, I'll call that C, I'll call that D. A, C, B, single marked, double marked, single marked, double marked. Okay, working with the triangle on the left first. Its right angle is D, and it's got the single marked angle, which goes on the left at A. Its third corner is C. The triangle on the right side has its right angle at D. It's got the double marked angle, which goes on the right side at B, and its third corner is C. Okay, AC is Y. It's there and there. AD is X, goes there. DB is 9, goes here. BC is Z, which goes here and here. DC is 12, which goes here and here. Okay, matching up sides. I want to solve for X. X goes with 12. And between those two, I can also pair up the 12 and the 9. X over 12 equals 12 over 9. 9x equals 144. 144 divided by 9 is 16. Okay, pairing up to solve y. Y goes with x or 12. Between those two, though, I don't have another set. So let's try the other y. Y goes with, I don't have another set. So, here's the thing though. I've got this unmarked side here, AB, and AB goes from here to here. AB is x plus 9. So I can put that here, or I know what x is. X is 16. 16 plus 9 is 25. Now let's try pairing up. This y went with this z, or sorry, with that 12, and then 25 goes with z. Not helpful. Okay, this y went with the 25, and I don't have a pair that works there either. Sometimes this happens. It doesn't mean you can't solve it. The problem is that they go with z. We need z. That's essentially all this is saying. I have to solve for z before I can solve for y. Z goes with either 12 or 9. But the top two triangles, I don't have other things to pair up. So I'm not going to put it with the 12 here. I'm going to put it with the 9. And then I can do 25 with z. So z over 9 equals 25 over z. Z squared equals 9 times 25 is 225. Square root, and z is 15. Now that I have that, now I'll be able to solve for y. Because now I know that this right here is 15, and this right here is 15. So when I make my pairings, y goes with 12, and I can do either this 15 with this 9, or I could have done the 25 and the 15. Either way, I should get the same answer. Y over 12 equals 15 over 9. Cross multiply, 9y equals 12 times 15 is 180. Divide by 9, and y is 20. Now, we are getting towards the end. We've got these two problems and then the last page. These problems say solve the right triangle, meaning finding all the missing sides and all the missing angles. So, on this triangle, first thing I look at is, okay, I know angle C is 90. Across from it is side C. Angle B is 50. Across from it is side B, which is 12. And then that makes this side A. I personally solve for the item which I know 2 of. I know 2 angles, so I'm going to solve for the third angle first. Angles in a triangle add up to 180. So angle A is 180 minus the 90 and the 50 we know, making angle A a 40-degree angle. Make sure angles are capital. Next thing I'm going to do is I'm going to solve for my side lengths. I'm going to solve for side length A. Now, to do that, I'm going to use trig. I'm going to focus in on this angle. This is the opposite. This is the adjacent. This is the hypotenuse. The hypotenuse I don't know. I don't know the adjacent either, but I'm solving for that one. So I'm going to work with adjacent and opposite. Ooh, remember, so, ka, joa. Opposite and adjacent is tangent. Tangent of the angle equals the opposite divided by the adjacent. Always multiply by the denominator. That way those cancel out. A getting multiplied by tangent of 50 is equal to 12. To get A alone, I divide by tangent of 50. That cancels out. And 12 divided by tangent of 50 is 10.07. Make sure you're using lowercase because it is a side. Now I also want to solve for side C, and I can use Pythagorean theorem at this point, or I personally prefer to stick with trig. Opposite I know, hypotenuse I don't, and I'm looking for opposite and hypotenuse is sine. Sine of the angle equals opposite divided by hypotenuse, multiply by the denominator because the variable is in the fraction. C times sine of 50 is equal to 12, and divide by sine of 50. Twelve divided by sine of 50 is 15.66. Had you done Pythagorean theorem, keep in mind that sometimes it'll be a little bit off because of rounding. This one would have been 15.67 had you done Pythagorean theorem. Okay. Next one. This one I know 2 side lengths, and I'm looking for the third first off. And then I have to find the 2 angles as well. But this one, because I know 2 sides, to find the third one, I'm doing Pythagorean theorem because side lengths are connected by Pythagorean theorem. This is my hypotenuse, so that goes into the C part of Pythagorean theorem. So 2 squared plus b squared equals 5 squared. That's 4. Subtract that from both sides, I get 21. To get rid of the square, I take the square root. Square root of 21 is 4.2. 5/8. I still need to solve for my angles. I'm personally going to solve for angle A first. That would make this my opposite, because now I'm mixing together sides and angles. That means I'm going to be doing trig. This is the adjacent. The adjacent's an ugly decimal. I'm not going to use it. I'm going to use the opposite and the hypotenuse, which means I'm going to do sine. Sine of the angle, which is angle A, is equal to opposite divided by hypotenuse. Since the variable is the angle, I'm doing my inverse trig. A is whatever sine inverse of 2/5 is. Type it into my calculator. Rounded to the nearest degree because it's an angle, and I would get 24 degrees. Now to solve angle B, I could do inverse trig again, or now I know two angles and angles of a triangle add up to 180. So I'm definitely going to do that. That would give me that angle B is a 66-degree angle. Okay, final page. Final page is all about setting up your triangle and then solving using either trig or Pythagorean theorem depending upon the problem. So, on this, do include a picture. David is building a ramp that has a 20-degree angle of elevation. Now, angles of elevation always go from a horizontal, upwards, angle. So it's going to do that, and then we're going to pull this down to create our right triangle. Now the angle of elevation was that angle by the horizontal, and it was 20 degrees. If the ramp is 3.5 feet long, now the ramp, any ramp is the slanted piece. So that's 3.5 feet. How far off the ground, in other words the height, does the ramp go? Mixture of sides and angles, I'm doing trig. Focus angle, opposite, hypotenuse. SOHCAHTOA tells me to do sine. Sine of 20 equals opposite divided by hypotenuse. Get x alone, multiply by the denominator because it's in the fraction. If you have watched this entire thing, you've heard me say that a lot. By now, you should know that if the variable is in the fraction, you're multiplying by the denominator. That way it gets rid of the fraction completely. You're left with whatever the numerator was. Since x was alone, I can start typing into my calculator, and 3.5 times sine of 20 is 1 point. We're rounding side lengths to the nearest hundredth still, so it ends up being 20 because the 7 makes the 9 increase, and the 9, when it increases, has to move a spot. Ooh, and it's a word problem. Don't forget the units. It's a side length, so that's in feet. Problem 2. A gymnast's springboard has a 15-degree angle created from its base and the ramp of the board. Okay, so there's a ramp. And there's a base. Bases end up generally being on the bottom of things. It's a 15-degree angle. If the board has a vertical distance, vertical is up and down, how long is the ramp? Again, the ramp is the thing that goes at the angle. Angles and sides together, trig. That's my angle of reference. This is my opposite. This is my hypotenuse. Hey, I'm doing sine again. Sine of the angle equals the opposite divided by the hypotenuse. Variables in the fraction, multiply by the denominator. X times sine of 15 equals 6. To get x alone, I divide by sine of 15. Six divided by sine of 15 is 23.18. This is a side length, hence I'm rounding to the hundredths. And that should be in inches, because it's a word problem, you should have units. Which we don't actually need the x equals at the very end because there was no x in the original problem. We chose x arbitrarily. A small step stool measures 3.75 feet at an angle. So in other words, at a slant, and in 3 feet vertically. Okay, so that's 3.75. What is the angle of elevation? Angles of elevation are horizontal upwards, so I'm solving for that. Mixture of side and angles, I'm thinking trig. Angle of reference, that's the opposite. This is the hypotenuse. Dang, it uses sine a lot. Sine of the angle equals opposite divided by hypotenuse. Want to get x alone since it's stuck in the angle? I do inverse trig. Cancel, cancel. I'm left with x on that side, and sine inverse of 3 divided by 3.75. Now this is an angle, so I'm rounding to the nearest degree, is 53 degrees. An angle of depression made with a roller coaster. Angles of depression go horizontal, downwards. Angle of depressions go up here. If the roller coaster travels 98 feet on its descent, now when roller coasters descend, they don't go horizontal, they don't go straight down generally, they go at the angle. That's the 98 feet. What is the vertical distance? That's this, traveled by the roller coaster. Horizontal distance, hey, this wants you to solve for both. There's my angle. That's the opposite. This is the adjacent. That's my hypotenuse. I'm going to solve for x first. Opposite, knowing the hypotenuse, is sine. Sine of the angle equals opposite divided by hypotenuse. Variables in the fractions, so I multiply by the denominator. That'll leave x alone. So I type 98 times sine of 35 into my calculator. It's a side length, so round to the nearest hundredth, I get 56.21. I also want to solve for y. Just moving this over a bit. So this time I'm working with the adjacent, and I'm going to work with the hypotenuse again. So cosine of the angle equals the adjacent divided by the hypotenuse. Variables in the fraction, so I multiply by the denominator. Again, that's going to leave my variable alone, so 98 cosine of the 35-degree angle of depression, rounded to the nearest hundredth, is 80.28. Final problem says a TV's measure is determined from the length of its diagonal. So if I have a TV, TVs look kind of rectangular. The diagonal is how you measure a TV. If a TV's horizontal length is 80 and its height is 30, how large is the TV? In other words, what is this length? Since in my right triangle that's hanging out here, because here's what I'm focusing in on, that's my right triangle, I notice I'm only working with side lengths, so I'm doing Pythagorean theorem. This is my hypotenuse. 30 squared plus 80 squared equals x squared. 30 squared is 900, 80 squared is 6,400. Add those together, I get 7,300. Square root of 7,300. This TV happens to be 85.44 inches.